Okay, in this video, we are going to take a look at the quiz for lesson 4.12, the standard normal curve. I'm going to go over each of the questions with you. I'm not going to give away the answers, but I'm going to go over each one and get you started. Number one says, use technology or the Z distribution table on pages A1 to A2 in the reference guide to find the indicated area. The expression P of Z is less than 2.87 represents the area under the standard normal curve below a given value of Z. What is the probability that Z is less than 2.87? Okay, so for this one, we're going to take a look at that Z distribution table, and we're going to find Z of 2.87. Okay, so on the left-hand side here, you can see that we find 2.8 in the first column. That means that the proportion or the decimal that we want is in this row right here. Then to decide which value we're going to take, we're looking at the 7. It's 2.87, so we have to find 0.07 up at the top. This is going to tell us that we want this column right here, so the value that we want is 0.9979. Okay, so that's for number one, and that's how we read the Z distribution table. Let's take a look at number two. Use technology or the Z distribution table to find the area indicated. This one says, what is the probability that Z is greater than negative 1.53? Okay, so for this one, negative 1.53. Negative 1.5 is right here. So we're going to follow this row across until we get to this column, 0.03. Okay, let's go back again. Negative 1.5, 3. So it's this value right here, 0.0630. But be careful, it says the probability that Z is greater than. All of these probabilities or proportions that you find in the table are all the probability that Z is less than some value, okay? When the question asks you if Z is greater than some value, you have to take your value and subtract it from 1. So to answer this one, you're going to do 1 minus 0.0630. Let's take a look at number 3, okay? Number 3 says, use technology or the Z distribution table to answer the question. The scores on a standardized test are normally distributed with a mean of 500 and a standard deviation of 100. Jake scored 500 on the test. What percent of students scored below Jake? So for this one, we're going to use that Z distribution table. You're going to use it. You're going to go look it up. But to use that table, we need a Z-score. And we don't have a Z-score yet. Okay, but we do have all of the information we need to find a Z-score. So we're going to use our formula. Z equals X. Your X value is, in this case, 500. It's the value for Jake's test score, minus mu. Mu is the mean. And for this one, the mean is also 500 over sigma. Sigma is the standard deviation. Standard deviation is 100. Okay, so you're going to simplify this expression. 500 minus 500 divided by 100. That's your Z-score. Go look up that Z-score on the table, and that will be the answer to the question. That will be the percent of students who scored below Jake. Let's take a look at number 4. Number 4 says the scores on a standardized test are normally distributed with a mean of 500 and a standard deviation of 100. Suppose 6,000 students took the test. Approximately how many scored above 490? So to answer this question, first we have to convert this X value of 490 into a Z-score, just like we did in the previous question. We're going to use our formula for Z. Okay, using our formula for Z in the numerator, we have X minus mu. In this problem, X is 490. That's the score that we're concerned about. And 500 is mu. That's the mean. In the denominator, we have our sigma. Sigma is the standard deviation, and that's equal to 100. So I'm going to simplify this one for you just so that I can show you the rest of the problem. So when we simplify this, 490 minus 500 is negative 10. Negative 10 divided by 100 is negative 0.10. And that negative is really, really important. So when you're subtracting in the numerator, just be sure that you're always subtracting your x value minus your mean. Okay, so we have our z-score of negative 0.10. When we look that number up on the table, we get 0.4602. Okay, but we have to be careful because this question says how many students scored above 490. And remember, these z-scores are giving us proportions of values always below the z-score. So if your problem says above, you have to take your decimal and you have to subtract it from 1. So let's do that. Okay, 1 minus 0.4602 equals 0.5398. So what is that number? That is the percent of students that scored above 490. 53.98% of students scored above 490. But again, that's not what the question's asking for. The question asks how many. Well, we know the total. We know there are 6,000 students in total. How many scored above? Well, you're going to take this last step. What is 53.9% of 6,000? Okay, so that's number 4. And then finally, let's take a quick look at number 5. Number 5 says lengths of newborn girls are normally distributed with a mean of 49.2 centimeters and a standard deviation of 1.8 centimeters. Consider a group of 2,000 newborn girls. How many girls will be 51 centimeters or shorter? This is very similar to number 4. We're going to find a z-score. We're going to look up the z-score on the table, and then we're going to multiply that resulting decimal value times the total number of newborns. Okay, so I'll get you started. To find the z-score, you're going to use this formula right here. Your x value is 51. Okay, that's the value that we're concerned about. How many girls will be 51 centimeters or shorter? Your mean is 49.2, and your standard deviation is 1.8. You're going to do that calculation, okay? So you're going to find your z-score. Then you're going to look your z-score up on the table. This question says how many will be 51 or shorter, 51 or less. So that means that the resulting decimal that we get from the table is the decimal we're going to use. We don't have to subtract it from 1. So you're going to take that decimal now. And remember, that's the proportion of girls that are 51 centimeters or shorter. We want to know how many. So you're going to take that decimal and multiply it by the total of 2,000.